Hello, ladies and gents. We are taking a look at our final look at the binomial distribution. Corporation has a number of vacancies to fill in a particular department. Offers of employment are made to 10 candidates. It's believed that for each candidate, the probability that the offer will be accepted is 0.8, and it's assumed that candidates' decisions are made independently. So let's take a look first of all at the parameters that we have here. N is equal to 10 candidates. P is equal to 0.8, which is the probability of success of them accepting the offer. So this is binomial. They'll either accept it or not. The P is the same for each candidate. And they're independent of each other, which is stated there. So this is a binomial problem. We're looking at what is the probability that between 6 and 8 acceptances are made. So when I say between, that would also be including 6 and 8. Oops, 6 and 8. There we go. So that's going to be the probability of 6 plus 7 plus 8. Now, here's the thing to note here is that this is going to be the probability of 6, 7, or 8 for a P of 0.8 is going to be equivalent to the probability of 4, 2, 3, and 4, which is 4, 3, and 2 for a P of 0.2. What are we talking about here? Well, let's take a look back at page, I think it was about page 8 or so. So I'm going to go back here. And, oops, a little further. There we go. It is page 8. Calculating probabilities for n is less than or equal to 10 and p is greater than 0.5. So in this case, p is equal to 0.8. So what we do is we're going to go to the tables and we're going to look for the n. And then we're going to go to the top and we're going to look for 1 minus p. So if we're looking for 0.8, we would actually go to the 0.2 column. And then what you do is you subtract the x from n and you look those values up in the particular column. So let's take a look at what that means here then. So going back to the page that we were just on here is, so what you do then is these two guys here are complements of each other. So the P is equal to 0.8. So when we go to the table, we're actually going to be looking under its complement of 0.2 because the table only goes up to a 0.5 column. And then these guys here, if you take a look at them, 10 minus 6 is equal to 4. 10 minus 7 is equal to 3. And 10 minus 8 is equal to 2, right? Because our n was 10 here. So you take n minus x, and you look these guys up in the table. So let's go back to the table here then. And that's going to be on about page somewhere around there. So we're going to look for an n of 10 right here. And then we're going to look at a p of 0.2. So it's right here. And then what we do then is we're going to take a look at these guys right here, right? Because that was equivalent to, originally, there were 0, 1, 2, 3, 4, 5, 6, 7, and 8. 6, 7, and 8, 9, and 10. So 6, 7, and 8 for a P of 0.8 is equivalent to a 2, 3, and 4 for a P of 0.2. So we're going to take a look at these three guys right here. All right, let's go back to where we were. And so the P of point for 4 was 0.0881 from the table. And then for 3 it was 0.2013. And then for 2 it was 0.3020. And that's equivalent to 6, 7, and 8 for a P of 0.8. And that comes to 0.5914. So 0.59, 59%. What's the expected number of acceptances that will be made? Well, this is a binomial distribution, so it's just simply equal to n times p, which would be n, which is 10, times 0.8 is equal to 8. So remember, what we're saying is that there's an 80% chance that each person will accept, and there's 10 people, so 80% of 10 is 8. That's all it is. What's the probability that less than 8 acceptances will be made? Well, you know how I do this is and x takes on the values of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then n minus x, because that's what we look at here, or just the reverse, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I always write them out this way because it helps me now when I take a look at this and say less than 8. Less than 8 means it doesn't include 8. It would actually be less than or equal to 7. So over here, it would be these guys right here. Right? So less than 8 would be 0 to 7. Now, what's interesting here is that it's probably easier. I mean, you can go to the table and just add up all those guys there. But what's left over here? What's left over are these guys. So this is equal to 1 minus the probability that x is greater than or equal to 8. So 8, 9, or 10. And that's for a p equal to 0.8. Now, the reason why I draw this over here is because you can see what the equivalent is for n minus x, because that's what we have to look up on the table when we're looking at 0.8. We have to go to the 0.2 column. So what this means then is this is going to be 1 minus the probability that x is, and take a look over here, the side. That would be x is less than or equal to 2, right? 8, 9, 10 is equivalent to 2, 1, 0 for a p equal to 0.2. Now, that's a lot easier to figure out. So that's equal to 1 minus the probability of 0 plus 1 plus 2 for a p equal to 0.2. Question that people will always give me at this point is, do we have to write all this down for the exam? And the answer is, no, you don't have to, but just make sure that you're grabbing the right numbers. So the more that you can show me, the better. So typing out your thought process actually is really useful here. So what I'm going to do is I'm going to go back to the table here then. And we're going to take a look at what we determined is that we were looking at 0, 1, and 2. So these guys, remember we're under the p is equal to 0.2 column. So we're actually looking at these guys right here, these first 3. All right, let's go back there. So that's going to be equal to 1 minus, and then grabbing those values from the column then will be 0.1074 plus 0.2684. I think that's right. And then 0.3020. Anyways, that does come out to 1 minus 0.6778, which is 0.3222, which is 32%. So there's a 32% chance that less than 8 acceptances will be made. All right, that's, I think, where we're going to end this. We will talk about this one here in class, and we will, just to remind you that there's additional problems at the end here, so work through these guys, starting on page B17, and I guess they're all on one page there, and so there's a number of them to work through here, and that will take us then to the normal distribution. So that's going to end the lesson here.